Okay, today we're going to look at solving equations with x squared terms, which means they're going to be quadratic, but we solve them, they're a lot easier to solve. So first, a little bit of review. If we want to find the average rate of change, we can use the formula, the slope formula. So y2 minus y1 over x2 minus x1 to calculate that slope or that rate of change. Remember, rate of change just means your slope, but put it in words. So if we want to look between hours 1 and 4, they specifically gave us 1 and 4, so we want to look there. So right between these two. So we can use our slope formula to plug those in. So 1 is 40, 4 is 297. And when we plug those in, we get 297 minus 40, 4 minus 1, which gives us 257 over 3. When you have a table, though, you could also subtract that. Just subtract backward. 297 minus 40 is 257, and 4 minus 1 is 3. So it'll give you the same thing. And of course, if we're looking at rate of change, we want to make sure it's in words. So this is y over x. That's what slope is. And so my hours since the observation began, time is your x, and then the number of bacteria, that'll be your y. So this is 250 bacteria, 257 bacteria for every 3 is my x, so 3 hours. So remember when we write rate of change, we do y, whatever our y is, and then our slope word, which can be per, each, or every, and then whatever our x is. So we did 257y is bacteria for every 3, which is x, and that is hours. So that is your rate of change. Okay, between the ages of 20 and 35. So we want to find the slope between those. So if I go to my age, I'm going to go to 20, and that one's hitting approximately 25. So 20 and 25. And then if I go to 35, that one hits at 15. So 35, 15. Then I can plug that in. 15 minus 25, 35 minus 20. And when I simplify that, it's going to give me negative 2 over 3. And again, we just have to put that in words. So this is my y over x. My y-axis is the money I spent. And my x-axis is my years. So this is negative, which means we are spending money. Our money is going down. So you spend $2. That's my y. And then pick a slope word. So I'm going to say every again. And then my x is 3 years. So I spend $2 every 3 years. Okay? Okay, use the graph at the right to find the following. What's the average rate of change on this interval? So we want to start at negative 3. We want to stop at 1. That's my start and stop. So if I go to negative 3, that one is hitting at negative 3, negative 3. And I'm going to stop at 1. So go over 1, follow that up. That is 1, 2. So I've got negative 3, 1, 2. Now we can't do rise over run on this. It's kind of weird because it's got this little like curve. So that curve, you can't really find the slope of that curve. So we just plug it into our slope formula and do our y over x. So we got 2 minus a negative 3 and 1 minus a negative 3. And that's going to give us 5/4. And they didn't give us words here. I have no idea what x and y are, so that is it. From these types of graphs, we can also determine if the graph is increasing or decreasing. So if I start at 0, these are my starting points, and these are where I stop. So if I start at 0, right here, and I stop at infinity, going from 0 to infinity, left to right, does my graph increase or decrease? It's going up, so it is increasing. Okay, the middle one, if I start at negative 2 on my x, so right here, and I stop at 0 on my x, go from negative 2 to 0, left to right, what does my graph do? It goes down, so that is decreasing. Okay, and then the last one, if I start at negative infinity, so over here on the left, and I go to negative 2 and I stop right there. So from negative infinity to negative 2, did it go up or down? It went up, so it is increasing. Okay, so that was our review. This is the new part. If we want to solve each equation for x, but we have x squared terms, or we have these parentheses, these double foiling parentheses, all we're going to do is we're going to FOIL this out like normal. So we got x times x, which is x squared, x times 3, so 3x, 2 times x is 2x, 2 times 3 is 6. I'm going to bring the other side down. Finish out my foiling, so combining my like terms. 3x plus 2x, that is 5x. And then for this one, I'm going to notice that these are exactly the same on both sides. When I get the exact same thing, that is infinitely many solutions. You could try to solve this out if you would like. When you solve it out, you're just doing sad meg, so we're going to get our like terms together. I have 2x squareds, so I'm going to subtract this one over. They actually both cancel out. So then I can take and get my x's together. So if I subtract my 5x over, that cancels out as well. So then that just leaves me with these 6's. And that is a true statement. 6 does equal 6. So because it's true, because all of my x's canceled out, and because that is true, it's infinitely many solutions. Okay, let's try B. So if I FOIL this out like normal, so x times x is x squared, x times negative 2, 2 times x, and 2 times negative 2. Same thing over here. FOIL this out, or you can do generic rectangle. So x times x, x times negative 3, 3 times x, and 3 times negative 3. Finish your FOIL by combining like terms on both sides. Negative 2 plus 2 cancels. Negative 3 plus 3 cancels. And then I can solve for x. So I need to get my x's together. So this is positive, so I'm going to subtract it out. X squared minus x squared, that's 0. That goes away. So then I'm just left with negative 4 equals negative 9. That is not true. Those are not the same thing. So this is no solution. So if all your x's cancel and it's true, it's infinitely many solutions. If all your x's cancel and it's false, it's no solution. Now, these do not always cancel out. I'm going to do a couple of your practice just so you can see that they will not always be no solution or infinitely many. So for number 1 on your practice, I'm going to FOIL this out. So if you need steps, if that helps you, FOIL first or generic rectangle. So x times 5x, x times 6, negative 1 times 5x, and negative 1 times 6. Finish your foiling by combining like terms. So 6x minus 5x, that's just 1x or just x. Now that I finished my FOIL, the next thing I want to do is start combining those like terms, but they're on opposite sides. So I have to use SADMEG. So I'm going to get my x squareds together first. So I'm going to move this one over here. It's positive, so I'm going to subtract it over. 5x squared minus 5x squared is 0. Bring down the rest. Okay, and then I'm just going to do my regular SADMEG here. I don't have another x term. If you do, you can do your x term. But if you don't, just do your regular SADMEG. So I have a minus 6 on my x, so I'm going to add it over. So 43 plus 6 is 49. Okay, number 2. So I'm going to FOIL like normal. But at this time I have FOIL on both sides. So x times x, x times 4, 3 times x, 3 times 4. And on the other side, x times x, x times 2, 1 times x, and 1 times 2. Finish your FOIL by combining like terms. So 4x plus 3x gives me 7x. And 2x plus x gives me 3x. And then I just solve this out. Get all my x's together. I'm going to do my x squareds first. So that's a positive, so I'm going to subtract it. X squared minus x squared cancels, and it should always cancel. We cannot solve these yet with an x squared term. We're not going to look at that today. So your x squared should always cancel, just like they did here, just like they did on the first page on the examples. So then all you're left with is your x's and your numbers. So if I want to get my x's together, that's a positive 3. So I'm going to subtract it out. 7x minus 3x is 4x. Bring down the rest. And once I get my x squareds out and my x's together, I'm going to SADMEG. Just do SADMEG. So subtract my 12. So 4x equals negative 10. And then divide my 4. So x equals, simplify that to negative 5 over 2. So FOIL first, then do your x's. Your x squared should cancel, and get your x's together. And then just do SADMEG. So like number 3, if I distribute, this one's not a FOIL because it doesn't have 2 terms to distribute. This one only has 1 number. So 2 times x, 2 times 1, bring down my plus 3, 3 times x, 3 times negative 1. I don't have any x squareds to cancel, so I'm going to get my x's together. So this is a positive, so I'm going to subtract it. So 2x minus 3x is negative 1x. I'm also going to combine these like terms. 2 plus 3 is 5. And then I can do sad meg. So I'm going to subtract. Negative 3 minus 5 is negative 8. And this is a negative 1, so I'm going to divide out negative 1. And x equals 8. Okay, I'll do one more where you have to FOIL and get your x squared terms out real quick. So I'm going to look at number 10. So remember, we FOIL if we can. This one does have FOIL. Then we're going to work with our x squared and our x terms. Our x squared should cancel, and then we get our x's together. Then we're just going to do sad meg. So we're going to FOIL this out because we do have two parentheses to FOIL, two terms. So x times x times 5, negative 3 times x, and negative 3 times 5. Finish up my FOILing by combining like terms. So that'll give me a positive 2x. And that's all my FOIL. Then I'm going to move to step 2. My x squared should cancel. So if I subtract that x squared out over to the other side, x squared minus x squared does cancel. Then I can get my x's together. I've got a negative 7, so I'm going to add it over. Do the opposite. 2x plus 7x is 9x. And now that my x is together, it's all about sad meg. So add my 15. Negative 15 plus 15 is 0. And then divide my 9 out. There we go. So my 9 goes away. And 0 divided by everything is 0. Very nice. Okay, the last thing on this lesson is just a little bit of a review of the exponents. So remember, you need to know if you should add, subtract, or multiply the exponents. If there's not an exponent, like if it's just x, write that 1 in there. Even if it's a number, sometimes we need it on the number, so you can write the 1 in there. And then your negative exponents, we flip them to the bottom. That means the reciprocal. And that's how we get rid of the negative. Oops, a little far. Okay. So, for A, we have x to the 5th times x squared. When we're multiplying, we're actually going to add those exponents. So, 5 plus 2 is 7. We don't have any negative exponents. It's no like terms, so this is it. Okay, b to the 7 squared. When it's outside parentheses, you can write this twice. So this is b to the 7 times b to the 7, which when we're multiplying our variables, we're going to add our exponents. So 7 plus 7 is b to the 14. Now we could also just distribute that 2. 7 times 2 is b to the 14 as well. Okay, for C, when we have division on our variables means we're going to subtract our exponents. So 4 minus 8 is negative 4. Now remember, we can't keep a negative exponent. So when you have that, you're going to flip your variable to the bottom. That'll make it positive. And if there's nothing left on top, technically it's an understood 1 in front. So that 1 just stays up top. Oop, my bad. Okay, for D, we're multiplying here. So our numbers are normal. This is multiplication. 2 times 3 is 6. But for our exponents, we're going to add x to the 3rd plus x to the 4th gives us x to the 7. And then I have a y, 0. There's no other y's to combine that with. And remember, 0, that cancels out. Technically, it cancels out to 1, but 6 times 1 is still 6. So that's not going to change anything. Okay, we got another division. Remember, division on your numbers is normal. Negative 15 divided by 5 is still negative 3. But for our exponents, we're going to subtract. X to the 6 minus x to the 8 is x to the negative 2. Y to the 5th minus y to the 8 is y to the negative, not 8, y to the negative 3. And we can't have negative exponents, so all those negatives on the exponent have to flip to the bottom. A number that is negative is completely fine. It cannot be an exponent. The coefficient is fine. So my negative 3 stays. Our negative variable, our negative exponents, those are going to the bottom and becoming positive. That is it. Okay, when your exponent is outside the parenthesis, you could write this out 5 times, or you can just distribute it. This 2, it has a 1 exponent, so I'm going to distribute my exponent. So 1 times 5 is 5, and I'll do the same thing on x. Negative 1 times 5 is negative 5. And then 2 to the 5th, that's 2 times 2 times 2 times 2 times 2. That is 32. And our negative exponents, remember those flip to the bottom and become positive. Okay, G, we have another fraction. Fractions are just division, which means on our exponents, those are going to subtract. So we don't have a number to divide our 3 by, so that's going to stay. X squared minus x to the negative 6. So this is 2 minus a negative 6. That becomes a positive, so that is x to the 8. And then there's no negative exponents or anything else, so that is it. Okay, we have another exponent outside the parenthesis, so we can write this whole thing out 4 times, or we can distribute it to the inside, to our exponents. So this is negative 3 to the 1st power, so that 1 times 4, that's going to be negative 3 to the 4th. That's x to the 1st power, so 1 times 4 is x to the 4th. And y to the negative 2 times 4 is y to the negative 8. So negative 3 to the 4th is negative 3 times negative 3 times negative 3 times negative 3. That gives me 81. X to the 4th is fine. But our negative exponents, they have to flip down. So it's going to go to the bottom and become positive. And our last one, we have another exponent outside the parenthesis, so we're going to distribute to our exponents inside. So x to the 1st times 3, that's going to become x to the 3rd. Y to the negative 2 times 3 is y to the negative 6. And then I can combine all these up. Negative 3 is my only coefficient, so I'm going to bring that down. My two x's, that's x squared times x to the 3rd. For my exponent, that means I'm going to add. So 2 plus 3 is to the 5th. And remember my negative exponents, they get flipped to the bottom and they become positive. Okay, so y'all try the practice on this one. Good luck.